So one of the characteristics, or actually can actually list several of the characteristics of a Cobb-Douglas production function. And a more general expression for the Cobb-Douglas production function, the more general expression is this. Q equals A times K to the little a power times L to the B, where capital A is assumed to be a positive constant. Little a is assumed to be a number between 1 and 0. Little b is a number between 1 and 0. Okay. This is the general form for the Cobb-Douglas. When you have two inputs, in this case capital labor. So this is called the Cobb-Douglas. Now, in the particular case that we just went over, what were we assuming about capital A, and little b? This is the general form of the Cobb-Douglas. The example we just went over, we assumed that capital A was equal to what? 1. Okay. And little a, we were assuming a minute ago was what? 0.5. And same for B. Okay. So this would be just a particular case of the Cobb-Douglas production function that we were looking at just a minute ago. This is the more general case. And what's interesting, I'll leave it for an exercise for you to show. What's interesting about this Cobb-Douglas production function, it always exhibits diminishing marginal productivity of labor. It always exhibits diminishing marginal productivity of capital. And the cross partial derivative, f sub kl, is always positive for this Cobb-Douglas case. The same thing we found in our particular case just a minute ago. Generalizes to this more general expression. Okay. So that's one of the reasons why this Cobb-Douglas production function is used so much in economics. It's a fairly simple function, but it exhibits important economic characteristics, diminishing marginal returns with respect to labor and capital, and a positive cross partial derivative.